Hi guys, it's Miss Marflack. We're continuing with solving log equations. You should have seen part 1 already, the video of part 1, and then now we're moving on to part 2. In part 1, we looked at two types of log equations, one where we scoop and loop around using the definition that had a log on one side and a constant on the other to solve for the x. And then the other type that we looked at was using the properties to condense first and then scooping and looping around, writing an exponential form to solve for x. And then at the end, we had to make sure that x, when we plugged it in, came out to be a positive number in the domain. This video is not that long at all. We're just going to go through 6 quick examples together. We're going to talk and we're going to add just one more property of logs, and we have our power, our product, and our quotient, and we're going to take a look at our one-to-one property of log. Now, you've seen this application before, the one-to-one property, or I call it the equality property, with our exponents, and that's when we have the same exponent, same base on both sides. Here, it's the same log on both sides. Then we have m is equal to n. All right, so it's a very simple property. It's actually kind of intuitive as well, and we're going to go ahead and we're going to start with number 1, and our goal here is going to be to solve for x. Take a look at number 1. We have log base 7 of 3x plus 2, and that is equal to log base 7 of 2x plus 5. Here's our one-to-one property in action. We have a log on both sides. They're fully condensed on both sides. They're the same base on both sides. So using that one-to-one property, that tells us that m is equal to n, and that's 3x plus 2 is equal to 2x plus 5. Then we go ahead and we solve for x, subtracting x from both sides and subtracting 2 from both sides, and we're going to get x is equal to 3. And then we just have to double check. Putting x equals 3 in here, we're going to get a positive number. Putting x equals 3 in here, we're going to get a positive number. Moving on to number 2, we have log. Now we're going to be doing our common log, our base 10, which is what most of our homework was working with. All right. Now we can see that these problems are different from part 1 because we have logs on both sides. All right, but my goal is to have one log of the same base on one side and one log of the same base on the other side, which means I need to condense this side first and get it to be one log. I see my addition with 2 logs, and I'm going to go ahead and use my application of my product rule, and that's going to combine to multiplication with 1 logs. And then now I can use that one-to-one property because they're the same base and we have 1 on each side, and I can go ahead and set x plus 4 equal to 4x. And then going ahead and solving for x, we have 4 over here, 3x on this side, and then dividing on 3 by 3, we get x is equal to 4 over 3. And then I can just double check. Well, if I were to plug 4 over 3 in here for x, I get a positive number when I add 4, and then when I plugged it in here for x, I get a positive number as well. Now we're going to take a look at one more example. These are the simpler ones, okay, where you just have log on both sides, same base. Maybe you have to do a little condensing first, and then this one's probably as hard as we're going to see it. All right, still going with that common log of x plus 2 minus log of 4x plus 3, and that is equal to log of 1 over x. Now, it may not look like it, but this example is actually very similar to the last in the sense that we have log on one side and 2 logs on the other. So my goal is going to be to condense these 2 first and then use that one-to-one property. I have subtraction with 2 logs, which means I'm going to go ahead and go to division with 1 log, and there's my application of my quotient property of logarithms. And then now I have 1 log on each side. They are the same base. I can use that equality or one-to-one property and just set my m on this side equal to my n on the other side. All right, and then now at this point, we're just solving a rational equation, and that's using our cross product. So I'm going to multiply those cross products. I'm going to have x times the quantity x plus 2 is equal to 4x plus 3. And then going down here a little bit more, distributing that x, well, that's x squared plus 2x. And then we're going to get everything to one side in preparation of solving this quadratic. So I'm subtracting everything and getting everything set equal to 0. We can condense those middle 2 terms, and then now we're looking, for those 2 numbers that multiply to -3 and add to 2, and that's going to be negative 3 and a positive 1. Using the zero product property, setting each one equal to 0, we get x can be 3 or x can be negative 1 or both. Now when I go ahead and I plug this back in, I plug 3 back into my domain. Well, 3 plus 2 is a positive number. That's good. 4 times 3 is a positive number. Adding 3 is a positive number. And then 1 over 3 is a positive number. So x equals 3 is an answer. But when I plug negative 1 in here, I get negative 1 plus 2 is a positive answer. That's good. Then I get negative 4 plus 3, and this is a negative domain. And that's going to be outside of our domain, so we cannot include that negative 1. All right, now those 3 examples is just our application of our new property 1 to 1. It's easy to identify because you have logs on both sides. If you kind of go back and look at that first video, you're going to notice every single problem we did together had log only on one side. All right, and then now, since this is the last video that I'm doing on solving log equations, we're going to do just a quick mix and review, just 3 questions, one from each type of log equations that we've looked at. All right, so we're mixing in now using the definition with scooping and looping, using the properties, and then using that one-to-one property. And then our directions here are still going to be to solve, and I'm going to start the numbering all over again. Here I am. This is going to be number 1. All right, this is actually the very first type of example we looked at together. This was our scoop and loop around. We're going to rewrite in our exponential form, and we had 5 to the second power is equal to x minus 7. And then 5 squared is 25, and then when we solved for x, we got x was equal to 32. And when you go back and you plug 32 in, 32 minus 7 will be a positive number. So that's an easy to identify because we have log on one side, nothing else besides the one log, and a number on the other. The next type of problem we looked at was using the properties to solve. Using properties. Sorry, I lost myself in my notes over here. All right, using properties to solve, you could see here that I had that 2 in front. I want to solve for x. I'm going to bring that 2 and condense fully, all right? So that was our directions when using the properties. First, condense both sides fully. All right, now I've used my power property, and then I can see I have log base 10 on both sides, and I can use now that one-to-one or equality property, and I get here that x squared is equal to 25. And then when I take plus or minus the square root, x can be positive 5 or x can be negative 5. But when I go ahead and I plug it back into the original problem, I get that this is a solution, and this one is an extraneous solution. All right, one more example to go here, and this is, one of the harder ones, and here I am, number 3. This is just like number 2 in the sense that we are not scooping and looping. Instead, we're using the property of logs to condense first, and then once we use the property of logs, then we can scoop and loop around. All right, here we are. I see on one side I have logs, and on the other I have just a number, so there's going to be no one-to-one property. At the end I'm going to have to scoop and loop, but I can't scoop and loop until these 2 logs are condensed. So I see a subtraction with 2 logs. That means I'm going to go to division with 1 log using that quotient property. All right, and then now that I've condensed fully and I have a log on one side, a number on the other, that's when we can write in exponential form, and that's going to be 2 to the 3rd power is equal to x plus 2 over x minus 5. Now, even though it doesn't look like it, this is a rational equation because 2 to the 3rd is 8 over 1, and I still have that x plus 2 and that x minus 5. All right, and then now we're going to use those cross products to solve, and I'm going to have 8 times the quantity x minus 5, and then I'm going to have that equal to my x plus 2. Solving for x, this is 8x minus 40, making sure we're distributing, and then I can subtract x. Ooh, I went off the page here. I can subtract x and I can add 40 to both sides, divide on through by 7, and we get x is equal to 6. And then we have to double check that in with the original problem. 6 plus 2 is a positive, and then 6 minus 5 is a positive, so that is an okay number for our domain. All right, so once again, we had 3 types of problems. We had the simple application of the scoop and loop. We had using the properties and then scooping and looping. And then we had our new video, our new one-to-one. All right, if you have any questions, please email me and get started on your homework.